Hello everyone, welcome back again to 𝙲𝚘 tutorials. In this video we are going to solve problems regarding with the pure substance. So we have here example number 2. Water at 400 kilopascal with a quality of 25% has its temperature raised 20 degrees Celsius in a constant pressure process. What is the new quality and specific volume? So in here we are going to determine the new quality and the specific volume. But first we are going to write all the given data for water, which is the change in T equal to 20 degrees Celsius and a pressure of 400 kilopascal, and our quality, which is 0.25 or 25%. So all these values here that is present can be found again in our property table in saturated water at P is equal to 400 kilopascal. So our saturated temperature at P is equal to 400 kilopascal, we have 143.63 degrees Celsius. And our specific volume for saturated liquid, which is 0.001084 cubic meter per kilogram, and the difference between the specific volume of saturated vapor and the saturated liquid, which is 0.46138 cubic meter per kilogram. So by finding VFG, you have to subtract the saturated vapor to its saturated liquid. So we have 0.46138 cubic meter per kilogram. So, and now for the solution of this, we have to first find the initial volume, which is VF, or our saturated liquid, plus our quality X multiplied by our or the difference between the saturated liquid and saturated vapor. So by plugging this given to our equation, 0.001084 as our VF, plus our quality, which is 0.25, multiplied by the difference between the saturated liquid and the saturated vapor, which is 0.46138 cubic meter per kilogram. So by plugging this into our calculator, we get the initial volume of 0.11643 cubic meter per kilogram. So next we can easily find the final temperature of this, which is equal to saturated temperature plus the change in temperature. So our saturated temperature is equal to 143.63 degrees Celsius plus our change in temperature, which is 20 degrees Celsius. So by plugging this to our calculator, or simply manual calculations, we get 163.63 degrees Celsius. So unfortunately, the new quality is undefined since the water is in superheated vapor state. So that means all the liquid that is present in, or for example in a cylinder, is being vaporized. So that means it's zero, so that's why it's undefined. So from superheated water table, at pressure is equal to 400 kilopascal and temperature at 200 degrees Celsius, the specific volume is 0.53422 cubic meter per kilogram, and from separated water table, pressure is equal to 400 kilopascal and temperature is 150 degrees Celsius. The specific volume is 0.47084 cubic meter per kilogram. So in order to find our final specific volume, we plug in all that we have here to here. So final specific volume is equal to 0.47084, which is our from the separated water table at pressure is equal to 400 kilopascal and T is equal to 150 degrees Celsius plus 163.63, which is our final temperature, minus 150 degrees Celsius from separated water table over by 200, which is from our superheated water table at P is equal to 400 kilopascal, minus 150 from our superheated water table at P is equal to 400 kilopascal, multiplied by 0.53422 which is from our specific volume at T is equal to 100 degrees Celsius, minus 0.47084, which is our specific volume at T is equal to 150 degrees Celsius. So, by plugging again this into our calculator, we get 0.4881 cubic meter per kilogram as our final specific volume. So that's it. Thank you for watching this video. I hope you learned something. Thank you.